about these buttons. So today, me and my partner Ayush are here to explain to you what these buttons and how to use a DSO. So a DSO is used to see the input and the output of a circuit that we are provided with. Let's look at some of the buttons. This is to start and stop the waveform, a running waveform. This is the power button. This is a multi-purpose knob. These are positioning knobs and these are scaling knobs. When we look at all the buttons when we connect a waveform and learn from there. To connect a waveform, we need a probe. This is how a probe looks. To connect the probe, we connect it to these channels, yellow for channel 1 and blue for channel 2. When we connect this probe over here, we need to verify that the probe is working. To verify the probe is working, a part is given on the DSO to verify. We can see here it says a 5 volt 1 kilohertz square wave. So we will connect the probe and verify if we can see a 5 volt 1 kilohertz square wave on the screen. I'll turn on channel 1 and we see a 1 kilohertz 5 volt square wave. So we can say that this probe is working perfectly fine. Now let us go to a function generator and connect these probes to a function generator. Now I have connected the probe to a signal generator that is producing a sine wave of the specifications, a 1 kilohertz frequency and 10 volts of peak to peak voltage. So now let's look at these buttons and see what they do. Let's turn this menu off. This is used to position the wave on the graph. So if I rotate this, I can see the waveform moving up and down. This, let's set it back to 0 divisions. We can see it is set to 0 divisions. Now the voltage is across the y-axis, it is symmetrical. Now let's look at the scale knob. When I rotate this, I can see the number of the boxes used is increased. This is the scale of the graph. I can change and manipulate the graph using these. I can see here that right now it says one box is equal to 5 volts. Now it's 2 volts, 1 volt, 500 millivolts. So this is how I manipulate the scale of the graph. Let's set it back to 5 volts. Then this is to move the graph horizontally, move the waveform horizontally. I can see that it is moving forward and it is going back with this. This button is used to change the scale on the x-axis. I can see the waveform is a little less spread now. It is being more compressed, and this is to increase the divisions on the x-axis. I can see that it is now a 50 millisecond every division. So this is why we can see the graph like this. Let's get it back to a nominal value. These are to move the waveform around the graph. Now let's look at some of these cursors. When we press the cursor button, we are given the option to use a cursor. When we select amplitude, I can use this multi-purpose knob to move a cursor so that I can measure the values. So if I set cursor 1 just at the peak of the waveform and cursor 2 just at the bottom of the waveform, just like this, I can see the difference between these cursors. It is approximately 10.4 volts, which was given to us in the peak to peak as 10.6 volts. If I can also use it as cursors in the y direction on the time axis, so I can use this to set it to some value. Suppose I set it at the peak here, so I can see it's at the peak. It's a 5.4 volts, it's at the peak, and I can use cursor 2 to change to get it to the next, I can get it to the next peak. So this way I can measure the time distance. It has 1.2 milliseconds, which comes, when we look at the frequency, it comes to 1 kilohertz. There is another menu option in the cursor button, the source. So suppose I had another waveform connected to channel 2 over here. So there would be two waveforms, a yellow and a blue one. So if I had to change the cursors on the blue waveform, I would select source as channel 2. The other sources, we learn about them later. So suppose I go to channel 2. Since there is no input waveform on channel 2 right now, we can't see anything and it says off over here. So let's go back to channel 1. This is the cursor button. Let's close this. Let's turn them off. Let's close the menu and let's go to the next menu, that is measure. Measure is used to have different values that you can measure. Right now I have selected frequency and peak to peak. I can select the period, I can select the minimum voltage, maximum voltage, mean, cycle mean, cursor mean, and all the things you can find from a graph of a waveform. These are the things I can measure. That the same for channel 2, and that is what we do in the measure menu. Let's turn the menu off. Help menu is to help you learn about this. This is a way to read about this and learn about this. So it has teaching enabled, so that's why we have this help button, in which there is the default settings and the default readings, how to take them. Let's turn this off. Let's exit. Then we have this run and stop. Suppose I set the trigger to a value that is outside the waveform and the waveform starts to run. As we can see here, the waveform is running and I want to stop this waveform, so I will use this run stop button to stop the waveform at a particular value, and then we can measure. Let us get the trigger back to 0 division so that the waveform doesn't run anymore, and let us run this again. So now it is a stable voltage, stable waveform without moving. Let's look at this search button. This is the zoom button. So there are two possible zooms allowed, the scale zoom and the position zoom. When I select the scale zoom, I can change the part I want to zoom into. So now I'm looking at this part of the waveform. Now I'm looking at just this much part of the waveform. I can reduce it to this much and I can see the values and the graph markings. The other one is position. In this, I can move the waveform to a particular value after scaling it to whatever I wanted. So now I am looking at this part of the waveform, as you can see here, and I can go ahead till the ending of the waveform on the graph. Currently, we are at a factor of 10x zoom now the position is 100%. So that means this is the end of the waveform that this DSO is currently showing us. Let's turn this back. This button is used to save this to a USB. We can input a USB here, insert a USB here, and when I select these, I can save this waveform in the form of an image or a comma separated values, that is .csv file, into the USB, and I can open it on my computer. This is to set it to default values, which we don't want, so we set it back to auto set. When we do auto set, it comes to the values that in which we can see the whole graph. These are the buttons that you can use to learn about DSO in basic. Let's now look at the math button that is there. First, let's see that there are now two input waveforms to this in channel 1 and channel 2. Channel 1, that is the yellow channel, has a sine wave of frequency 1 kilohertz and a maximum voltage of 5.6 volts, while the blue channel has a frequency of 1 kilohertz and a maximum voltage of 53 volts. So it is a 10 times waveform. Now let's look at the math function. When we go to math, there are 4 menu options: operation, sources, position, and vertical scale. Let's look at each of them one by one. Operation. This is used to do the operation between the two channels, either plus, minus, or multiplication. Let's select subtraction. When we select subtraction, we now between source channel 1 and channel 2. The red waveform is the equivalent waveform of channel